Okay, another example of annuity. So this is here we got a present value of annuity of $100 per year that makes first payment 2 years from now. The discount rate is 9%. So our formula, our calculator, are only going to give us the result for this period. Okay, so the present value of those cash flows. So this was, I don't know why we have, okay, yeah. So we have 4 payments of $100 beginning in year 2. So that is $323.97. We have to present value that one more year. I'm going to flip over and do this on the calculator here in a second. So that actual value is the $327.97 divided by 1.09. That's $297.22. Let's go to the calculator. All right. So we had we have we got 4 years. They were let me hold on let me look at our, there we go. All right, so we're hold on, there we go. I'll get the calculator up here. So 4 years at 9%, so that's 4N 9IY. There's no money in that account now, so 0 present value. We're calculating the present value, sorry. So $100 payments and 0 future value. We compute PV. So this is our value in year 1. So we take that and divide it by 1 plus the rate, 1.09, and we get the $297.22. So, all right. So, okay. So, growing annuity. Growing annuity is a growing stream of cash flows with a fixed maturity. We've got to consider our growth rate in each year. It looks kind of similar to our annuity calculation, but we have to consider that growth rate. So the present value of our cash flow is the cash flow divided by the required rate of return, or rate of return, minus the growth rate, multiplied by 1 minus 1 plus the growth rate, divided by 1 plus the rate of return, to the t power, and the 2 would be the number of periods. Your time value of money keys will not handle this type of problems. You can, if you don't want to use this formula, you can use the cash flow function and grow the cash flows each year and do the cash flow calculation that way. Or another way, and probably the easiest way, is to use Excel. So, growing annuity example, $20,000 defined benefit. Retirement plan offers to pay you $20,000 a year for 40 years, and with a 3% annual increase in payment each year. What is the present value of retirement if the discount rate is 10%? So Again, $20,000 growing at 3%, so 20 times 1.03 in the second year, 20 times 1.03 to the 39th power in the 40th year. So the formula be 20,000 divided by the discount rate or required rate of return of 10% minus the growth rate multiplied by 1 minus 1 plus the growth rate divided by 1 plus the discount rate, 2 in this case, the 40th power. That's $265,000, what that the present value of that 40-year income stream would be. Another example of a growing annuity. So you're evaluating an income generating property. Net rent is received at the end of each year. First year's rent is $8,500. Rent is expected to increase at 7% each year. What is the present value of the income stream over the first 5 years if the discount rate is 12%? So our cash flows, $8,500 in the first year, 8,500 times 1.07 in the second year, or $9,095. 8,500 times 1.07 in the third period, or $9,731.65. The 8,500 times 1.07 to the third power, or $10,412.87, and then the fifth year, 8,500 times 1.07 to the fourth, $11,141.77. So we could calculate this. The easiest way to calculate this would be the present value, that should be PV, is equal to 8,500 divided by the 0.12 minus 0.07, and then we multiply that by 1 minus 1 plus 0.07 divided by 1.12, and then this is 5 years to the fifth power, so that would should give us the $34,706.26 as well. The other fairly simple way to calculate these is using a graphics calculator if you happen to have one. All right, so next we'll talk about loan amortization.